Yeah. Fascinating title, I know, but hopefully it'll be more interesting than that. I'm going to talk to you about what happens when there's an incident on the road network. So in these sort of circumstances, you can't use data in the sort of same way James was talking about, because these events are usually unique in space and time. So you need to kind of look at what's going on at the sort of heart of the system. So what's driving the resulting congestion in response to this incident, and this boils down to how people behave. So we want to look at how people respond to congestion, how they respond to an incident in the road network, and how that affects the rest of the system itself. So individuals can be represented in this respect in three ways. We want to look at how do people really choose a route between origin and destination, or what influences their choice, whether their knowledge of an area influences their decisions, if they make different decisions according to how much they know of the network, and whether they use information to guide them, things like sat-nav and, I don't know, radio and stuff like that. And so what we're trying to do is incorporate all of these behaviors into agent-based simulation where a more full heterogeneity of the behavior is incorporated and resulting in a more realistic representation of real-world phenomena. Okay. Right, I'm going to turn the lights off. I'm sorry, but you know, it's more exciting that way. This behavioral aspect, in order to get a better sort of idea of the influence of it, we can look at, well, we use agent-based simulation to really dig into that. So this is a video Tao showed a minute ago. This is basically an example of one of my simulations. You can see little bits sort of moving around. This is showing building up of saturated roads and stuff like that. But if we actually extract data out of these simulations, which you can do in the same way you can extract traffic data in real life, you can look at how the way you define an individual, the way that you define how they behave, influences the network characteristics. So in this case, we define our individuals as using, when they're going between origin and destination, they're taking the shortest distance path. So what we see is like there's loads of cars go around here, quite a lot go around Euston Road. So this area is quite loaded, right? But if we define our individuals in a different way, the whole system changes. So this is defining agents so taking the least time path. You get a big shift of traffic onto these main roads, loads of traffic disappearing from these central roads, which are a bit obscure. You look at least angular routes, you get a different representation. You look at least turn routes, you get, again, a different representation. So what this is saying is that the way we define how people behave really affects our results and the quality of our results. So what we're trying to do is get a really good understanding of how people behave in this sense. So in this case, how they route around. The other thing I'm looking at is spatial knowledge, so how much they might know of an area. So this is what happens when, in comparison to the base case, the original number, shortest distance routes. This shows the shift in patterns again, a lot more movement to the main roads because people only know the main roads, they know around their origin and destination. So that's showing that shift. And again, you define the knowledge in a different way, you get a different representation. So we're trying to, we're using a bit of data, we're using a bit of theory, we're putting it all together and trying to get a decent, a bit of light, decent representation of what happens on the road network. And that's it.
Very good.